All right, in this video, I'm going to go over how to find inverse functions. So kind of a brief overview of what an inverse function is. I'm hoping you guys saw this in Algebra 1, but if you didn't, that's okay. Basically, when you have an inverse of a function, you're going to take all of your x values and all of your y values, and they trade places. So like in this first example, you can see Miss G put her beloved LSU players as her x values, and her position, the position they play, as the y values. So if we want to find the inverse of this, I'm going to switch each of these. I'm going to copy that over here. Oh, let's do this. That way I can do the whole thing. There we go. So I'm going to take these players, and they're going to be my new y value, and then take the position that they play, and they're going to be my new x value. Okay, so just going to trade those spots. All right, so with numbers, and hopefully how you saw this in Algebra 1, is if you look at that ordered pair 1, 3, it's going to become 3, 1. Same with the next one, 2, 5 becomes 5, 2, then 7, 3, 9, 4, and finally 11, 5. All right, so that's how we do it. We switch the x and y's. Now, one thing that I'm going to try to help you guys with in terms of in the class and discover this is that whenever you graph inverse functions, all right, they are actually always reflected across a certain line. All right, so I'll go ahead and graph this line on there for you. All right, I'm gonna use my ruler to help me. And when I do it, I'll do a dotted line so you don't think it's part of the actual graph. All right, or a dashed line. There we go. Okay, there's that one. And this one here, line those up. Perfect. And you can notice that what I'm graphing is the line y equals x, which hopefully, as we do more of these, will start to make sense because they're just switching places. So like, for example, this one here is our parent quadratic function, which is x squared. And so this parabola on its side is the function plus or minus, I guess I should take away function, it's not a function, make this mathematically correct, is the relation y equals plus or minus x. Okay, and those are reflected across y equals x. These two here are both linear, reflected across that same line. Now I'm going to show you guys how we can find those inverses using algebra with these steps of switching the x and y variables, solving for the new y, and then depending upon what letter they use, or if it is a function or not, we'll be using the function notation ones, or we'll use this one here, y to the negative first power, which tells me that the inverse is actually not a function. Okay, so here we go. Let's try the first one. So first thing is you write y equals 1/2 x minus 3. So replace the function notation with the letter y. Then you're going to switch the x and y variables. And now I'm going to isolate for this y. So I'm going to move the 3 over, the minus 3 with adding, to write x plus 3. And then to get rid of that 1/2, I'm going to multiply both sides by 2 to get 2x plus 6 equals y. Now I know this 2x plus 6 is a function, it is a line, so I can go ahead and write my inverse as g to the negative first power of x equals 2x plus 6. So that's the notation we use when the inverse is a function. Okay, let's do the next one. So I'm going to write y equals 1 over x plus 5. This is actually a pretty basic rational function that would look like this, where you move it 5 units up. So you have an asymptote at y equals 5. I'll use a different color. An asymptote at y equals 0, excuse me, x equals 0. And the graph, we just finished these. The graph looks like this. Okay? So now we're going to find the inverse of that. So now I'm going to switch x and y. So x equals 1 over y plus 5. Subtract the 5 to get 1 over y. Now the way I do this is I'm going to multiply both sides by y to get y times x minus 5 equals 1. And now I want to move that x minus 5 to the other side. So I divide it by x minus 5. So I get y equals 1 over x minus 5. And this is a function, right? It's actually a very similar function, but this time your vertical asymptote is at positive 5. The horizontal asymptote is at the x-axis, y equals 0. And the way it looks is like this. Okay? So I'm going to go ahead and rewrite this as a to the negative first power of x equals 1 over x minus 1. Okay, let's go to C. Write y equals. Switch the x and y. I'm going to move the 2 over with multiplication to get 2x equals y minus 1. Add 1 to both sides, and you get 2x plus 1 equals y. Again, that's a line. So this is a function. So h to the negative first power of x equals 2x plus 1. Okay, let's try this next one, D. Y equals 2 over x minus 3. Switch the x and y. X equals 2 over y minus 3. Just like I did in the one above it, I'm going to do the same thing. Show less work. I'm going to do it in my head. So I move the y minus 3 to the left side, and I move the x to the other side with division. So it's 2 over x. Again, if you need to show all those steps, take your time. And then finally, move the minus 3 over with plus. And again, that is a rational function. So it's going to be n to the negative first power of x equals 2 over x plus 3. Okay, one more. All right, so we have y equals x squared plus 3. Switch the x and y. Notice I did not switch the square with it, right? You leave everything the same, just the x and y switch. All right, if there's an exponent, leave the exponent where it was. Move the 3 over with subtraction. All right, now here's the thing. I want to get rid of that square. So I do need to take the square root of both sides. But when I do that, I need to make sure that I put plus or minus in front of this. And this is where kind of like alarm bells go off my head when I do this, because if I graph this, that's 3 units to the right. So again, we have this piece. Ooh, try that again. We have this piece. But because of that plus or minus, I also have the piece down here. So it's a parabola on its side, which fails the vertical line test, right? Pretty much everywhere, actually everywhere except this vertex. Okay, so because it doesn't pass the vertical line test, it's not a function. So we're going to write y to the negative first power of x equals plus or minus the square root of x minus 3. All right, just to show you that this is actually not a function. Okay, it is a relation. All right, guys, so that's it for this. Check out the homework. There's lots to practice. It even asks about domains. We can talk more about that in class if you have any issues finding the domain of these inverses. All right, good luck.